It's beginning to look a lot like statistics. Every school you go, take a look, oh, it's 12:10.
Use the coordinate plane to sketch a graph of the given characteristics. If the graph is not possible to sketch, explain why. So the first thing I'm going to do is a degree of 5. So a degree of 5, the easiest, that's an odd or an even. And the easiest odd we know is, so this is x to the 5th, the easiest one is x to the 1st, and that graph is just a line. As you go from left to right, starts down, ends up. Okay? Then it says starts in quadrant 2 and ends in quadrant 4. So if I were doing this without the graph, let's pretend the answer's not there, right? It says starts in quadrant 2, so if you don't know your quadrants, you go counterclockwise. 1, 2, 3, 4. Okay? So it says start in quadrant 2, and then it says end in quadrant 4. Okay, now look, this verifies, these two, pink and blue, this verifies that it's an odd, right? Because they're not in the same position. Okay, now it says a relative maximum at x equals 3. Now we've done this before, basically that means on the line itself, on this yellow line somewhere, there's got to be a mountaintop. Does that make sense? A peak. Doesn't matter where you put it on this yellow, but it better be a high point. That's the point. And then a minimum on y equals -3. So I go on the x-axis to -3. You don't need to draw this orange line, but I'm trying to help you see it. And then somewhere on here, there should be a low point. So low point on the orange, high point on the yellow, and then sketch your graph. And that's what your graph could look like. Okay, so that was question number 7. Let's try number 8. Even degree. Kevin, what's the easiest even degree we know? X to the 2nd. What does that look like, Kevin? But x to the 2nd, or an even degree, what does that look like? A U. Opening which direction? Up or down? Up. Now it says increases from x equals -2. Let's give ourselves a visual. Increases to -2. So my graph's got to be going up until this point. Does that make sense? So like my pen, it's going to be like this. That's increasing. Going up from left to right. Then decreases to x equals 0. What a crazy graph. Then increases to x equals 2. And then it decreases to the end. Okay? A relative minimum at y equals 1. Okay, now pay attention. If it has a relative minimum, that means on this point here, notice I'm turning my ruler now. Anywhere on this line, there is a low point. And then the last one, a maximum, 2 absolute maximums at y equals 4. So it means at this point in blue, I'm going to have 2 maximums. Okay? Okay, let me think about this. Get a pencil ready. If it's a maximum, can I have a maximum here, class? Class, is that a maximum? What do you think that means here? It didn't tell us, but I'm going to have to flip the graph. The a value is negative. Do you see that? The reason why I know that, because it tells me 2 absolute maximums, so that means there has to be the graph has to be pointing down, which means my arrows, let's draw that. Do I have enough colors? Orange. My arrows for my even degree polynomial is going to be starting down, ends down. Okay? And then we said 2 absolute maximums at y equals 4. So I'm just going to draw, this is the mountains. Okay? And let's put the minimum maybe in between it. So it's increasing up to -2. So actually my graph should actually go, it's got to increase to here though. To right there, that makes sense. Right there. If you mess up like I did, just draw a really big dot right there. And then it's going to go down to this purple line. That's where my minimum is. And then it goes back up to this point. So that means that's where my absolute maximum y equals 4 is. And then there's my minimum on the green line. And then it says it decreases. So something like that. Kind of looks like a transit, huh? So use your characteristics, mark it on your graph, and then try to sketch it out. I was a little bit more confident, but if you're not as confident, use a pencil and so you can erase. -5, -2, 1, and 3. And has a y-intercept at -4. It's an odd degree polynomial, so x to the third, which is just like x to the first, starts down, ends up, but the -a value changes how the graph starts. So it's going to start down, end up. Pink. Alright, so if I try to sketch this, I'm thinking to myself, if I sketch this, let me do it in pencil. I don't know, you could do something crazy, I don't know. Maybe it bounces, it comes back and goes through there. Something like this, right? Not an accurate picture, but something. And then let's just count the number of extrema. Count with me, ready, set, go. So if I get 4 extrema, what was that formula we used, Brittany, from the previous page? Okay, so if we just counted 4 extrema, right, and I put in here 4 equals degree minus 1, and then if I'm trying to solve for degree, if I add 1, class, what type of polynomial did we just draw? We just drew a 5th degree polynomial, but it tells us it's a what? 3rd degree polynomial. Okay? Uh-oh. So class, is this a 3rd degree polynomial? No, the answer is you can't draw it. Can't draw because there is too many extremas, that's the one I just explained to you, and x-intercepts. So we're not supposed to be able to draw this picture. Here's the second explanation. You can write this down as a formula. The degree equals the max number of x-intercepts. Degrees equals the max number of x-intercepts. Let me show it to you. Class, what degree do we have in this problem? 3. So we should have a max number of x-intercepts. We should have 3 x-intercepts at most. Count with me. Ready, set, go. Too many x-intercepts. Does that make sense? So it's okay if you start drawing it like I did, but it gave us some clues. Some of you didn't even need to see that, and you just saw the degrees and the x-intercepts, and you could have written this explanation, which tells us that you can draw. Right, f of x approaches infinity. What does that mean? That is the y value. Someone said up. So as I go towards the right, let's color code this. As I go towards the right, my graph is going to finish up. As x approaches negative infinity, which direction? We're going to the left. As we go to the left, f of x approaches negative infinity. So that means down on the f of x or the y. So as I go towards the left, finishes down. Has a y-intercept of y equals -2. So that means it's going to cross our y-axis at y on the y-axis, so the y number line at -2. It has 3 x-intercepts. Doesn't tell us where they are. I'm just going to put them between my 2 arrows, so maybe something like 1, 2, 3. I don't know. Hopefully that works out for us. And then it says 2 relative extremas. Say again? Oh, good job, you. -2. Thank you. And then 2 relative extremas. Those are just some high points and some low points. I'm going to put those between my x-intercepts. So how about something like right there and one in between there. Alright. Your favorite at the restaurants? Connect the dot. So I'm going to go from left to right. Here I'll approach this x-axis, and my next kind of color is right here in purple. So why don't we do like something like a bounce. And then in one of the extrema, so that means I have to kind of go up here. And this is what my graph looks like. Pick one. Okay. What do you know about even degree polynomials? Hey, what? Okay. So you're thinking like something like this, right? Like a U? Okay. So the big idea there is that it should start up, end up. Raise your hand if you got that so far. Good. Alright, Jocelyn. Give me something else. Okay, so here, it's saying that all of the y values are -4, so like 3, -4, 2, -4. So based on the y's, I'm going in this direction. On this purple line, you will hit a minimum. Okay? Thank you. Alexis? Okay. Kinda weird. It's saying that the absolute highest point on our graph is on this line. Okay. Thank you. Jesse A. Last one. How would you describe an intercept to someone, an x-intercept? I just walked in, I have no idea about math. Say, Jesse, what's an x-intercept? Ah, it touches the x. So you can just randomly put in 6, right? 1, 2, 3, 4, 5, 6. Huh. That's weird. I'm supposed to start up here and then eventually get to here, right? But saying the blue line is the maximum, yes? If I move the pink one over here, can I do something like that? Does that work? Oh no. Can I do it like that? Oh no! Look at this. I have how many x-intercepts? I have 6 of them. But, okay, let's go back. So it's an even degree polynomial, 6 intercepts. This equals the degree. So, does this work out? Even degree and a 6 degree polynomial? Huh? 6 is even, so it works. We're okay? But it's saying that I need an absolute maximum. Is that true? You know, you brag to your friends, oh yeah, I went to a really high mountain, and then right behind you in the picture is another sign that says, oh, go up there, there's a higher mountain. Does that make sense? So in this problem, you can't draw. Because the A value is positive for an even degree polynomial, but it has an absolute maximum. Does that make sense? It's saying that if I drew my polynomial, something like that, right? Is this the absolute highest of the highest class? No, right? You're probably just thinking like on campus, but there's like bigger mountains. Something way up here. Does that make sense? So that's why you cannot draw the graph.
Alright, characteristics. Always decreasing. Put your pencil down and show me a decreasing function. We read in left to right. That means the graph going left to right is going down. Class, is this an even or an odd degree? This is an odd degree polynomial. So degree odd. Now, I know it doesn't tell us, but I kind of just want to, this is some big ideas, right? What's an odd number? 1 is your easiest. Okay. Is the leading coefficient positive or negative? Raise your hand positive. Raise your hand negative. Okay, the leading coefficient is negative. Why is it negative? Because if I put a negative in front of x to the first, x to the first normally looks like this. But with that negative sign, it just does this. Here's an awesome thing. I don't know. This thing called the graphing calculator. And if I just type in negative x, it will tell me what it looks like. Oh, I only have 20 more in the cabinet to check out that no one's using. So, I can put my arrows, watch this, in colors. I know it's going to do something like Okay? Put your finger on the y-axis. Put your finger at negative 2.5. Y-axis, negative 2.5. And put your finger at an x-axis. Put your finger at the x-intercept of negative 3. And your graph just needs to kind of go somewhere. So I know that the problem didn't ask you for the degree and it didn't ask you for the leading coefficient, but these are kind of like some basic tips that kind of helps us. We're going to eventually build upon these characteristics.
On the 12th day of math, Miss Mr. gave to me 12 packets scanning, 11 discriminants, 10 parabolas, 9 x boxes, 8 times tables, 7 vertex forms, 6 y-intercept, 5 expressions, 4 fx functions, 3 practice tests, 2 wag forms, and the axis of symmetry.